where are we going to start?
Pounds.
We start with pounds, right? Zeke is 165 pounds, was 165 pounds. What can I change Zeke into? Kilograms. I can change pounds into kilograms. I get, in your book it says 2.20 pounds is 1 kilogram, right? Now, you could stop here. You could memorize that I need to divide and change it into kilograms. Lord help you if you're going to memorize all these conversions, okay? The analogy I just gave them is I'm kind of rolling through all the stop signs. If you stop at each step, that's like turning your car off every time you get to a stop sign. I'm just going to kind of make sure my units work. Pounds cancels, doesn't it? So now I'm in kilograms. So this step works. Now the next step is I have to find something to change kilograms into something else. I can change it into milligrams because this fact right here tells me that 1 kilogram needs 10 milligrams of medicine, right? So kilograms cancel. I'm almost there. Do I have a way to change milligrams into tablets? One tablet is 50 milligrams. So milligrams cancels. And I'm left with tablets. Does anybody notice how I write these things? Do you know which one I write first? Anybody notice? I write the one that cancels. I always write the bottom first. Why? Why do you think I write the bottom first? Because it cancels. If this unit on the bottom doesn't agree with the unit that I had on the previous one, then I did something wrong, didn't I? Okay? Now the easiest part is what? Multiply, multiply, divide. How many tablets do you have to stuff down poor Zeke's throat?
15.
How many? 15? Big dog, you have to get some bigger pills for him. We use that soft cream cheese. I don't eat it, the dog eats it. Does that make sense? We're good? Happy? Maybe? Do you think you'll ever have to do this calculation again in your life? If you're going to be a nurse or a vet tech or even a dietitian, you're probably going to do this calculation so many times you get sick of it. Now here's a funny little fact. Don't y'all repeat any of this, okay? Last semester, I do some other projects on campus, and I was talking to a couple of nursing instructors over there. And I said, hey, some of our students have been calculating dosages, and they do it different than we do it. What do you mean they do it different? They're like, well, they were your students, and they said Dr. Powell taught us how to do this. And I said, well, are they doing it wrong? And they said, no, they always get the right answer, but we don't know how they're doing it. Because they were doing it just like this. And our nursing instructors had some little formula in the book that said, when you have this, multiply this, or when you have this, divide this. They didn't understand the units on it like this, like I do, and like you do. This will never fail. You'll never have to learn that stupid formula they have. So when I showed them an example, like a cooking example, like converting things that you're going to cook or something. And they're like, that's it? And I'm like, yeah, that's it. But they didn't understand how to change these units like this. This will always work. I have students every semester come to me and say, thank you for teaching me how to do this. Because it works every time when you do dosage calculations, okay? Fair enough? Mac, how you doing? You look tired. You okay? Tired. You just want to take a little nap? Go ahead, we won't say anything. All right. Well, let's do something that's a little bit different. Let's do some metric conversions. In the slides, there's one that says a rattlesnake. Who likes rattlesnakes? Anybody like rattlesnakes? No. Great boots if you get rattlesnake boots. is 1.44 meters. I want to know how many inches is that? And I want you to do it this way. You have to use this fact. 2.54 centimeters equals 1 inch. Must use that fact. How's that?
She got it.
You got it now?
Yeah.
Good. Where were you struggling? Show me where you were struggling.
I get confused with the marking.
Oh, yeah, you only mark out the unit, not the actual number, right? The unit gets marked out, not the number. 100. Very good. So 100 what? Is there 100 meters in 1 centimeter? Or 100 centimeters in 1 meter? See what I'm saying? So the question is, a lot of you are struggling with this. Is it 100 centimeters equals 1 meter, or is it 100 meters equals 1 centimeter? Is a centimeter bigger or smaller than a meter? It's smaller, right? We use it. You guys use a meter stick in a lab, right? There's 100 centimeters in a meter, isn't there? No. There's 1,000 millimeters in a meter, right? Gotta learn your prefixes. Centi is small, right? There's a lot of centimeters in a meter. So this is the fact you need, right? But there's 100 centimeters in a meter. Because now we're going to do 1.44 meters. And we know that 1 meter is 100 centimeters. Fair enough? What did I just do? I just changed meters into centimeters, and now my units went from being meters to being centimeters. And students in the other section say, well, why do you want to do it this way? If I look in the book, there's a conversion that says 1 meter is 39 point something inches. I said, well, because this one's exact. I know exactly what this one is. It never changes. And it's one that I've asked you to know, right? I asked you guys, I said, you're going to have to know this. It'll be on the quiz and it'll be on the midterm, guaranteed. Look, you already got like 2 questions ready to go. Now what do I do? What am I going to do now? 2.54 centimeters is 1 inch. And the unit centimeters cancels, doesn't it? And I'm left with inches. Ms. Warren, how many inches was that?
56.7.
56.7 inches. Is that a lot of inches? Is that a lot of inches? How tall is that? How long is that?
Almost as tall. It's almost 5 feet.
Yeah. If we want to convert it to feet, what would we do? 12 inches is 1 foot. So you divide that by 12. 4 3/4 feet. About as long as you all are tall, isn't it? What are you arguing about? 4'10", 4'11"? It's almost as long as you. That's how tall you are, not how short you are. Okay? Practical? Yeah. That's a big snake. Particularly a rattlesnake. I choose not to mess with it. Would make a mighty fine pair of boots. Right? Fair enough? Okay. So that's an introduction to doing conversions and dimensional analysis. Definitely recommend you go home and do all the practice there is. There's plenty of these problems in chapter 2 homework. Okay? And if you still are not comfortable, go into the book and work the odd number problems in the book. Okay? The odd number problems will help you. Because the answer to the odd numbers are in the book. Generally in the homework, I ask the even numbers. And then if you want more practice, you can go work the odd numbers. Okay? Or you can come ask me questions too. Okay? So, that's a good introduction to dimensional analysis. Now, you can do another slide. All right. One of the things we haven't talked about is percentages. Okay? Did it this morning?
Mm-hmm.
What didn't y'all do this morning? Here, you come on up. No? Now the book uses a good example, and I don't like using this one, but I guess it's okay. There's a thing going around about percent body fat, right? What do you think that means? Body mass index is a terrible number because it's based on a population that was never intended to be used for an individual. That number. It's a terrible number. Percent body fat is a much better number than BMI. Because you look at my body structure, even if I lose 50 pounds, my shoulders are still going to be huge. I'm a big guy. My son, I can show you. You've been in my office. You seen a picture of my son? Mm-hmm. He looks just like me. Yeah. You know, he don't have this yet. He will eventually. Right now he's muscle because he's 17 years old. Plays football, right? So he's all bulked up. BMI would say he's way overweight. But he's not really. He's got some fat on him, but he's not huge. He's not that fat, not like his daddy. Okay? Percent body fat's a much better number because what does it do? It tells you how much of your body is made up of fat. Like those muscles, it used to be a big thing. Bodybuilders, right? You see those guys? If you were to calculate their BMI, they would be like obese, some of them. But they have no fat. Body fat's a much better number. Body fat means what? It's normally calculated as pounds of fat divided by pounds of body. So your pounds of fat in your body divided by your total mass times 100. Anything over about 30 is considered obese, right? Anything over about 20 is considered overweight. Ideally, you probably want around 12 to 15%. Particularly women, it's going to be a little bit higher than men. Because you guys have these things here growing inside of you, parasites. Think about it, it really is. It really is a parasite. So you need extra fat to feed that parasite. Men don't need that. We just like to drink beer and eat, right? Okay. But also women float a lot better because they have extra body fat. So when you swim, women traditionally float much better than men do. So parts divided by the total times 100. Okay? We can do another example with that, and we can talk about students. In here, I have one male out of 18 total students. So what percentage are male?